class. And Dr. B, thank you for joining me. My name is Letitia. Good morning. And I'm going to be talking about correlation and causation, correlation versus causation today. And please, if you have any pen, you want to write any questions down, any comment, please feel free to do so and post it or email it to me, and I will get back to you on that. And also, I might be talking a little fast because I only have 15 minutes based on YouTube. So if I'm going too fast, I'm actually going to show you a reference list. So if you want to read up on something, you can certainly know where to go and find out more information, okay? So let's get started. In research, correlation and causation get mixed up a lot. It's confusing for some people, and probably because maybe the misunderstanding or just a strong desire for some people to find plausible explanation for a scientific observation or research. Either way, being able to distinguish or identify, recognize the difference between those two concepts cannot be overstated because they both mean two different things. So today my objective is to talk to you about the definition, give you some examples, go over the difference between the two and some of the type of study you can do per each concept. And my hope is by the end of this discussion, if you don't have any information about this, you'll be able to get some information. And if you already know a little bit about it, then I hope to kind of expand your knowledge some more. Okay. All right. So let's talk about correlation. And when we're talking about correlation, we are referring to the relation between two data, two information, two things. So again, correlation, we are looking at the relation between two data. And an example for correlation is this scatter plot graph. Again, I got it from Lady 2013. If you want to read more about it, I believe it's chapter 9. Please feel free to do so. In this graph, we have the two data we have is age and reading level. And so it's from 6 years old through 13 and from 1 to 8. So based on this graph and further information, we can see that there's a relation between these two data. Because the dot that is showing the child's age and the 0 that is showing the reading level is very closely aligned to the middle, to the mean. So, and they both are going up. Okay, so what we are seeing here is the older the child gets, the higher the reading level also gets, the higher he or she reads. So we are seeing that there is a relation between age and reading level, which are two data. Okay, so that's an example for correlation, and a study that you can do to find out this type of information is a correlational study. And a correlational study, according to Lady 2013, is examining the extent to which differences in one variable relates to another variable. Again, in this case, it will be age and reading level. So we will say that a correlation exists, or if there is a relation between two data, if when one variable goes up, another one goes up or goes down. And in this case, you can see that one variable, meaning age, goes up, and reading level, meaning which is another variable, also goes up. So so there is a relation that exists between those two variables. And after the study, the statistical results is called correlation coefficient. It's also known as R squared. So in the future, if you come across R squared, is referring to the statistical result of the research, and it's a number between +1 and -1. And so when we see a statistical result, which is correlation coefficient, from +1 to -1, it will tell us two things. It will tell us the direction of of the result, and also the strength of the relation. Excuse me. So if the result, if the number, excuse me, of the statistical result is anywhere between +1 and -1 in any direction, if it's closer to any direction, we will say that there is that the relation exists and is strong. But if it's +1 or -1, then we will say that the relation is perfect. So again, the closer the number gets to 1 in either extreme, the stronger the relation exists between those two variables. And if a number is on a plus side, that is telling us that as one variable went up, the other one also went up. So the direction is going upwards. And if the number is closer to the minus sign, then it's telling us that as one variable went up, the other one came down. Okay, so that is correlation. And so let's go ahead and move on to excuse me. So we talked about strength. So like I said, the closer it is to each extreme, the stronger it is. Okay, so that would be strength. So and if it's +1 or -1, it is strong. So and we say that we have a perfect correlation or perfect relation between those two data. All right, so let's go ahead and talk about causation. Causation, unlike correlation, where we are trying to figure out if there is a relation. Causation, we are not so much interested in if there's a relation. We are more looking into we are looking into what causes what led to what. That's what causation is looking into. And an example of that is Sam's work hours. When Sam worked 20 hours, he earned $30. So the less hours he worked, the less money he made. The more hours he worked, when he worked 40 hours, the more money he make. He earned $60. So by Sam, who works hourly, get paid hourly, when he works less hour, he makes less money. So it cause and effect. So him working less hour is what caused him to make less money. So again, with causation, we are looking at one thing causes the effect of another. But in research, a researcher will say that will conclusively say that one variable cause the effect of the other variable if every other variable has been eliminated. If any other explanation that can also give us to lead us to that result has been eliminated. For example, for Sam, a researcher would say that yes, him working less hour is the cause of him earning less money if every other thing, such as his pay rates get dropped, the Sam called out from work, what other things can explain the reason why he earned more money. Any other thing that can explain the reason why he earned less money, as long as they have been eliminated, then we can conclusively say that him working less hour is what caused him to earn less. Okay, so and that is basically referring to internal validity of the study. So for a researcher, for a study to have internal validity, every other plausible explanation, other variables needs to be drastically reduced or eliminated for it to have that. So those type of variables are called confounding variables. So again, they are variables, they are any other explanation that can explain our results. So they need to be eliminated except the only thing that we are being looked at. Okay, so we have in the experimental design, we have an independent variable and dependent variable. So if you're looking into what causes what, you're looking at the independent variable and dependent variable. An independent variable is the thing that the researcher manipulates, and the dependent variable is the thing that reacts as a result of the independent variable. In other words, the dependent variable depends on the independent variable. Okay, so I will give you an example of that just right now. So let's just say that let's take a look. Let's just say that this is a stick, and this cap is a golf ball. Okay, and so our dependent variable is this golf ball, this stick, and our independent variable is this stick. So dependent variable, independent variable. Okay, so the dependent variable, which is the golf ball, or in this case a stick, the golf ball, in this case a water cap, is going to react as of however I manipulate this independent variable. So its reaction is based on this. So this is gonna cause this. Okay, so let's go ahead. So me shoving this stick is me manipulating this independent variable. So I shoved it once, and the golf ball moves. Okay, and it didn't go that far because I didn't shove it hard enough. So if I shove it hard enough, it moves across the hall. So its reaction is based on this. So again, that cap will be dependent variable, and this will be independent. Its reaction is dependent on this one. Okay, so I hope you got that. And let's see, I have an example for physical example for a relation. If you will give me one moment. And so while my assistant is getting my example for a relation between two variables, I want to show you my reference. So I hope you can see it. This is my reference. Okay. So I hope you can see it. So if you have any other questions, please feel free to go back here and take a look. All right. So let's go ahead and put this down, and let's go. So this is my my physical example. So this is Ephraim. Say hi, Ephraim.
Hello.
Ephraim goes to the gym often, so he lifts weight frequently. So we were discussing, and I was asking him questions, and he believes that there's a relation between frequency of weightlifting and his biceps. Okay, so do you believe so?
Yes, I do.
Okay, can you show us a bicep? So you believe that there's a relation between you going, how often you go to the gym, and your biceps?
Yes, there's a relationship between how much biceps calls I do and how my biceps develop or grow.
Okay. All right, so thank you for sharing that with us. So that's an example of a relation. We haven't done an actual study on that, but again, if you have any questions, feel free to go back to my reference, or this is another example that we talked about. So one thing that I want you to get out of this, let's recap it really quick. For correlation, I want you to get out few things, okay? So correlation looks at a relation between two between two variables, between two things. And so the statistical result from a correlation is called correlation coefficient, or is this is used to calculate a correlation coefficient. That's okay. Correlation coefficient. And the number is between +1 or -1, If the number is plus, that means the variables are going up. If the number is minus, the variables are going down. And the closer it gets to either extreme, the better, the stronger we will say that the relation exists. And if it is either plus one or minus one, then we will say that it is perfect. Okay. So that's what I want you to get out of that. For causation, we are interested in what caused what moved as a result of what, and what has an effect on something else. That's what we are interested in looking at. And again, we have dependent variable and independent variable. Independent variable is the one that we manipulate to see the reaction of it on the dependent variable. And again, with cause and effect, we need to make sure that the internal validity, we have internal validity, and the way we will make sure of that is by making ensuring that all other plausible explanation for our result has been eliminated, meaning all other variable that can also lead to our result has been eliminated, except the one that we are studying. And that's it for those. So I have a quick question before we wrap up. Two kids named Johnny and Amy were arguing. Johnny comes from a wealthy family. Parents has a lot of money. Both work, and Johnny has a 3.6 GPA. Amy comes from a single parent household. The father doesn't work, which is the father, he doesn't work. He receives stipend from the government. And unlike Johnny, who has one sibling, Amy has 4 siblings. So one day at recess, both kids were arguing, and Johnny tells Amy, "I am smarter than you." And Amy said, "What makes you think you're smarter than me?" Johnny said, "Well, my GPA is higher than yours." Amy now tells Johnny, "Well, your GPA is higher than mine because you come from a wealthy family. Is because your GPA is higher. You are doing better in school as a result of your parents' wealth." So in essence, what Amy is telling Johnny is that his parents' wealth directly affects how well he's doing in school. So my question to you is Amy correct? So that's a cause and effect. Do you believe? Do you see a relationship between? So Amy is mentioning 2 things, 2 variables. Johnny's family income level and Johnny's GPA. So let me ask you, do you believe that there's a correlation between those 2 variables, income level and GPA? Great. So yes, there is a relation between those 2. Actually, research has proven there's a relation between those 2 variables. Well, let me ask you, do you believe that one causes the other? Do you believe that Johnny's school performance is as a result of his parents' wealth? Great. It's not. It's not a result of his parents' wealth. And the reason is because, remember, we talked about, for us to conclusively say one thing causes the other, we need to eliminate every other possible explanation for that result. And in this case, we don't know if Johnny says extra in school and raises his hands and asks questions in class. We don't know how often he studied. We don't know if Amy cuts class sometimes and don't study, even though the book might be in the library, she might not study. So there are other things that we have not taken out of the equation that will not allow us to conclusively say that Johnny's income is as a result of his parents' wealth. So that leads me to tell you that based on Lee 2013, correlation does not in and of itself indicate causation. So just because we have a correlation between 2 variables, that does not indicate causation. With Amy and Johnny case, we do see a relation between the 2, but that does not mean that there's a causation. Another example is rain and mud. Probability theory allows us to assume that, or say that rain, after it rains, mud increases. So, however, we cannot say that rain causes mud, because after if it hasn't rained for 2 months, you could go by swamp and it can be muddy. But if it rains that day and you go by the swamp, it can be it can be muddy. So it doesn't cause rain, but cause mud. Rain doesn't cause mud, but there is a relationship between the two. Okay, that will be all. Again, if you have any question, please post it. Thank you so much for sharing this time and watching. Have a good day.